Okay, so now some simple algebraic function and graph. Some simple algebraic function and graph. So in the first, so many functions are there. So for example, the first one is constant function. Constant function. What is called constant function? A function f is defined from a to b is said to be constant function if fx is equal to x. If fx is equal to x, for any values of x, you will get the result fx, and this is called constant function. So we can represent this constant function in a diagram. Then which type of diagram we'll get here? This is a linear, this is a straight, there is a graph y, this is x. Constant function means if you put the value of input is 1, you will get the result 1. If you put the value of 2, the result will get same result you'll get. That is, this is called constant function, or this is called identity function, you can say that. So some simple algebraic function and graph. So there is a first function is the identity function. Identity function. Identity function says that whatever the input will put, will get the same result. Just like we can define like that, a function f is defined from a to b is said to be identity function if fx is equal to x. That is why it is called identity function. So for any values of x, you will get the same result. If I will give the value 2, I will get the result 2. If 3, I will get the result 3. 4, I will get the result 4. That is why this is called identity function. Identity means whatever the input will give the same result. That is why this is called identity function. So there we can represent in a graph. So there is, this is the line. So here is the, for x is equal to 1, y is also 1. For x is equal to 2, y is also 2. X is equal to 3, y is also 3. So like that graph we can plot here. That is why this is called identity function. Now after that there is another function that is called constant function. Constant function. What is called constant function? So constant function is defined as a function f is defined from a to b is said to be constant function if fx is equal to c for any values of x. Fx is equal to c. It means if you put any values of x, always result will be the same. In the place of c, for example, you can take 2, 3, 4. So for example, we can See here, suppose if, for example, if fx is equal to 2, so it means if we have to draw this graph, then how we can draw the graph? This is y, this is x. If I will put x is equal to 1, y is 2. If I will put x is equal to 1, y is 2. If I will put x is equal to 2, even y is 2. Even x is equal to 3, y is 3. X is equal to 4, y is 2. So always the value of y is 2. So if we join this line, then we can see that this is called constant function. In this case, the value of y will not change. For any values of x, the y remains constant. That is why it is called constant function. So this way we can draw the graph of identity function as well as constant function. Okay, now the third one, see, there is a linear function. Linear function. Linear function means a function, if you draw the graph, you will get always a straight line. So even in identity function, there is a straight line, but there is a special type of graph is there. But in the linear function, you can define like that. A function f is defined from a to b is said to be linear if fx is equal to, you can write in the form of, this is the format, ax plus b. So here ax plus b, where a and b are, where you can write where a and b are constant. So in this case, so here is fx, the function which is in the form of ax plus b, you can see the power of x is 1 here. So in this case, you can say that this function is called linear function. Here power of x is 1. So in this case, linear function. So how to draw this graph? So here we can take some example here. Suppose I will take example y is equal to fx is equal to suppose 2x plus 3. If we have to plot, so we can plot by making some table. Here is x, y. You can take any values of x here. Any values of x we can take. We have to find two points, at least 2 points we need. So if x is equal to 0, then y is 3. If I will take another value of x, you can take any values, 1, 2, 3, minus 1. So you can take the simple value. So that makes you easy. So I will take 2. And what is the value here? 2, 2, 4, 7. Now we can plot x coordinate is 0, y coordinate is 3, x coordinate 2, y coordinate is 7. So we can plot like that. There is y axis, this is x axis. Here is x is equal to 0, y is 3. X is equal to 0, so y is 3. 1, 2, 3. 1 point is here, we have to plot. Another is x is equal to 2, 1, 2, y is 7. 1, 2, 3, 4, 5, 6, 7. So 7 is here. So you can join this. So this is a straight line. So if we join with the ruler, we have to join with the ruler. So I will use ruler to join. If you have ruler, then you can join this by ruler this way. We can join ruler. This way we can draw the linear function graph. So if any linear function, if power 1, then that is called the linear. And if we have to draw, so we can make a table. At least 2 points we have to select, at least 2 points. You can choose any values of x. Put here, get the value of y. And that point you have to plot on the graph and join this. This way we can find straight line. That is why this is called linear function. So now another is a quadratic function. Quadratic function. So quadratic function is defined as a function f is defined from a to b is said to be quadratic function if fx is in the form of ax square plus bx plus c. If fx is in the form of ax square plus bx plus c, where a, b and c are constant. So to be clear, in a linear function we saw that the power of x is 1, but in quadratic the power of x is 2. That is called quadratic function. So this way we can define the quadratic function. If even the power of only x is there, but their power is only one term is there, that is suppose x squared, that is also quadratic function. So we can take one example of quadratic function and what type of graph is there. Suppose I will take two type of graph is there. So y is equal to x squared. What is the graph? Just we have to sketch. I'm not going to draw by taking some point. You can draw by taking some point. Just there you have to find the nature. So their nature is, this is y-axis, this is x-axis. So here is y is equal to x squared, like that graph. If we have to draw, so very easily, if we can, any type of quadratic function is there, and if you can convert this in the form of complete square form, suppose x minus 2 whole squared plus 3, like that. This is also quadratic, because if you expand you will get the power of x is 2. So how can you draw the graph directly? How can you sketch this graph? So for that, here is like that. So y is equal to x square graph is there. Their vertex is at the origin. This line is called symmetrical line. This line is called symmetrical line because this both side is symmetrical about this line. So now y is equal to x minus 2 whole square plus 3. How to do that? So let's see here. Because of these two, graph will move horizontally, and because of 3, graph will move vertically up or down. If plus, graph will move up. If minus, the graph will vertically down. So there is minus 2, so graph will move left or right. If minus 2, so 2 unit right. By the way, if there is plus 2, then the graph will move 2 unit left. So here is minus 2 here. So this graph, you can suppose to be same graph, will move 1, 2 unit here. So this line, symmetrical line, move here. So here is the symmetrical line. Here is the symmetrical line. So because of 2 and because of 3, graph has to move vertically up. How many unit? 3 unit. So 1, 2, 3. 3 unit here is. From here, because the parabolic graph is like that, this is the quadratic. So from here, graph will move like that, this way. So this is the graph of y is equal to x minus 2 whole square plus 3. So this way you can understand what is called quadratic function and how to draw what type of graph of quadratic function have. So this way we can draw the graph of quadratic function. Now another one is a cubic function. Cubic function. So in a cubic function, a function f is defined from a to b is said to be cubic function if fx is in the form of ax cube plus bx square plus cx plus d. This whole format is this. Cubic function if fx is in the form of this, where a, b, c and d are constant. So here fx is equal to ax cube plus bx square plus c. So what we found the difference in the quadratic and the cubic. So let's see, in the cubic the maximum power of x is 3. In the quadratic maximum power of x is 2. In the linear maximum power of x is 1. So here is the cubic, maximum power of x is 3. So that is why this is called cubic function. So what is the nature of the cubic function? So let's see some example. If power of x is 3, then you can say this is cubic function. So I will write, suppose fx is equal to x cube. So what is the nature of the graph? How this graph will go? So their nature is like that. This is y-axis, this is x-axis. So here is this way. The graph will go this way. So this is the format of cubic function. Same type as I draw for the quadratic. If graph is like that, fx is equal to, suppose, x minus 2 whole cube, suppose minus 1. Then how we can draw that? Same process we can apply here. Let's see how. So there is y-axis, x-axis. What will happen? Because of 2, graph will shift horizontally or vertically. So because of this, graph will move horizontally. 2 units right or left. So I just said before, minus then right. If there was plus, then left. So minus 2 is 2 units right. So we have to move 2 units right. Here is. So this point goes to that point. Now because of minus, graph will move vertically down. Minus unit. Minus 1 unit here. Here you are. So now we are here. So from here, same type of graph we can plot here. Like that. So this is called cubic function. X minus 2 whole cube minus 1. This graph is like that. So this way we can draw the cubic function graph. Okay, now polynomial function. Polynomial function. So all the linear, quadratic, cubic also can be said that this is a polynomial function. But this is the more classified as a quadratic, cubic and linear. So just polynomial if you have to say, so we can say that a function f is defined from a to b is said to be polynomial function if fx is in the form of a naught xn plus a1 x n minus 1 plus a2 x n minus 2 plus da, 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 plus an up to there. So this is called polynomial functions. We can see here in the polynomial function the power is decreasing here and there is a maximum power of x is n, where a naught, a1, a2 to an are constant. So fx, this is called polynomial function where a naught, a1, a2, an are constant. So this is a generalized function. So if the power of n is 1, then that becomes linear. If the power of n is 2, maximum power of n is 2, then that is the quadratic. If our maximum power is 3, then this is a cubic function, like that, power 4, 5, all that we can say that. So this is a polynomial function. Now after that, after polynomial function, we can see that what is called absolute function. Absolute value function is there, or absolute, before absolute we can say the rational function there is. Rational function. What is called rational function? A function f is defined from a to b is said to be rational function if fx is in the form of fraction, algebraic fraction. So we can say that px over qx, where qx is not equal to 0, and we can say that, and px and qx are polynomial. This is called rational function. So for example of the rational function we can take, for example, fx is equal to, suppose, 2x over x plus 1. This is the example of the rational function. The function which is in the form of fraction, where the numerator and denominator are the expressions in terms of x, where px and qx are the polynomial in terms of x, you can say that. So 2x over x plus 1, this is the example of a rational function. Okay, now another function is a absolute value function. Absolute value function is defined like that. A function f is defined from a to b is said to be absolute value function if fx is in the form of modulus of x. So this is called absolute value function. So this can be defined as, I explained before about the modulus function. So there is modulus, how to define modulus? So modulus of x is equal to x if x is greater than or equal to 0. Modulus of x is equal to minus x if x is less than 0. So if we have to draw this graph, so we can draw like that. Suppose y is equal to modulus of x. If the value of x is greater than or equal to 0. So if x is greater than or equal to 0. If x is greater than or equal to 0, so modulus of x can be written as x. So we can write y is equal to x only. And if x is less than 0, so modulus of x can be written as minus x. So y is equal to minus x we can write. Let's say the definition. If x is greater than or equal to 0, modulus of x can be written as x. If x is less than 0, modulus of x is written as minus x. So for x is greater than or equal to 0, this. So we know the graph of, now let's see how to plot the graph. The graph of y is equal to x is what? If you take x is equal to 1, y is 1. X is equal to 1, y is 1, one point is here. X is equal to 2, y is 2, another point is here. So the graph is like that. Like that. Or we can plot the graph like that. Make the table x, y, x is equal to 1, y is 1, x is equal to 2, y is 2, like that. But we cannot take, because here is x is greater than or equal to 0. We can take the value less than 0. So graph less than 0, the input is not less than 0, so graph will not extend this side. So only the graph will start from here up to infinity. For y is equal to minus x, what value of x we can take? Can we take more than 0? No, because the question is saying, here is saying x is less than 0. For that case, the value of x would be smaller than 0. So we can take, so smaller than 0, so we can, so because less than in the modulus function, we can start with the 0 there is. The graph will start from here. So because we cannot differentiate, yes, less than 0, but what is the value just less than 0, we can't say that number. So that is why we can take the value as from 0, we can say that from 0, so 0, and we can take another value as a minus 1, so y is 1, x is minus 1, so y is 1 there. So one point is here, another point is here, so we can draw a graph. This is called absolute value function. So from this graph shows that for any values of x, the value of y is always positive. So modulus function always gives the positive result. So from there, for any values of x, we can see the value of y is positive. This graph shows that. This graph, for any values of x, y is positive. For any value of x, y is positive here. So absolute function always give positive result here. So this way we can draw the graph of this. Now suppose if we understand y is equal to modulus of x, if we have to draw y is equal to modulus of x plus 2 plus 3, how we can draw? Just I explained before about the quadratic and cubic, same way. Modulus function we understand, and x plus 2, just we have to sketch. I'm not going to draw, to sketch. So there is x plus 2. So the graph will shift horizontally left or right. So what I said, if minus, so horizontally right, if plus, horizontally left. So there is plus, so we have to move 2 units left. So let's see here. So this is y-axis, this is x-axis, so this is -1, this is -2. So we are here. We are here because of this. Plus 3, it means we have to move 3 units up. 1, 2, 3. We are here. It means this is the point. So now here, this graph will draw here like that. This way we can draw the graph of y is equal to model x plus 2 plus 3. This way we can, by shifting, directly we can draw. Without plotting the point, if we understand the nature of the graph, just we can plot here. If you have to find what is the y-intercept, just put x equal to 0 here, so 5. So here is 5. So this way we can plot the graph of absolute value function. Now there is another type of function is there, greatest integer function. Greatest integer function. How we can define greatest integer function? So we can define like that. A function f is defined from a to b is said to be greatest integer function if fx is equal to like that for every n is less than equal to x is less than n plus 1, where n is greatest integer. This way we can define greatest integer function. So what does it mean? Suppose I will write f 2. Here is 2. So what does it mean? So let's see here, x is 2. So what value we have to take? Because equal to sign here, always we have to take this value. So 2 is an integer. So the integer is just 2 is the answer. If I will take another example, you can see f 3.5. So that is 3.5. What we can take there? Here is 3.5, value of x is 3.5. What will take? Always we have to take the n and n plus 1, both are the integer. So we have to take greatest integer. So 3.5, n is the greatest integer. So 3.5 here, so there must be 3, there must be 4. So we have to take 3. So 3 is the greatest integer here. So greatest integer function defines like that. Because not equal to, we can't take this value because equal to sign is here. Suppose I will take another example, f minus 2.4. f minus 2.4 is there. So minus 2.4, so what value will take as the greatest integer? So in a linear number line, we can see that in your linear number line, there is -2, there is -1, minus 2.4. Where is the minus 2.4? Minus 2.4 is -2 minus 2.4 is here. So here is -3. So greatest integer, there is n plus 1. N plus 1 is the bigger number and there is a smaller number. So there is a minus 2.4. Here is, we can take as there is a minus 3 is a greatest integer. So now another function is a trigonometric function. If any function is written like that, a function fx is written, I am not going to write all the definition here like that. Similarly, we can say that. So if function is written fx is equal to either sin x or fx is equal to cos x or fx is equal to tan x, so such type of function is called trigonometric function. This is the trigonometric ratio. So this is an angle. In this forms, if fx is written is equal to sin x, x is the input, their angle is the input here. So in this case, this is called trigonometric function. Now how to draw their graph of trigonometric function? So I will draw the graph of sine, cos and tan. Let's see here. I will draw sine, cos and tan. First of all, y is equal to sin x. The graph of sin x. So graph of sin x, there is y, there is x. So we know that trigonometric functions are periodic functions. So periodic, it is sin x is the periodic in 360 degree. So what do you mean by periodic function? So periodic function means, suppose sine 30 degree is how much? What is the value of sine 30 degree? So sine 30 degree is 1 over 2. You can add in 30 plus 360. How much is that? 390. Just check. What is the value of 390? So 390 is also 1 over 2. Sine 30 1 over 2. In 30, if you move 360 ahead, you will get the same result 1 over 2. In 390, again you add 360, you will get the same result. That is why it is called periodic. Just like, for example, in the chemistry you did in the periodic table. What do you mean by periodic table? In periodic table, what happened? In every after 8th element, we'll get the same group of element. Same group of element, just like sodium, there is a hydrogen, helium. Yeah. So what is the, in chemistry there is a hydrogen, helium, lithium. So after sodium, again that will come in the same group. There is a potassium. So after sodium there is a potassium. You will get like a in a same group that comes here. So that is called periodic. So after 8th element, you will get the same. The element have the same group, same physical properties, same chemical properties is there. That is why. So here is the trigonometric function is also called periodic function because it repeats some values, same values after some interval. So here is the sin x repeat their value in 360 degree. So now what is the maximum value of sin x? The maximum value of sin x is 1, minimum value of sin x is -1. So their amplitude is -1, 1 to -1. So there is, so I will divide this 360 degree in the interval of 90, 90, 0, this is 90, this is 180, 270, there is 360, there is -90, -180, -270, -360. I will draw only up to there, but graph will go up to the infinity. So at 0, sin 0 is 0. At sin 90, there is 1. 180, sin 0. Sin 270, -1. Sin 360, 0. So you can draw. This is the nature of the graph. Always you have to understand this is the nature of the graph. It will go up to the infinity. Sin -90, -1. 0, then 1, then 0. Graph will go like that. So this way we can draw the graph of sin x. What is the graph of cos x? Y is equal to cos x. Cos is also periodic in 360 degree. So in cos also we will take the same interval 90, 90 there is. So there is y, there is x. So 0, 90, 180, 270, 360. There is -90, -180, -270, -360. So here is, what is the value of cos 0? Sin 0 is 0, but cos 0 is 1. So cos has also the range of cos is -1 to 1. So maximum value of cos is 1. So at cos 0, 1. Cos 90, 0. Cos 180, -1. You have to plot here. So 270, 0. 360, again 1. Sine, there is 0. Sine -90, 0. -180, -1. And then 270, again there is 0. And 3 minus 360, there is again 1 there is. So graph will draw like that. So this way we can draw the graph of y is equal to cos x. So we can see that it is periodic in 360. You can start from here, you can reach here. From here, again from it start from 1 and again end with the 1. So there is, it is periodic in 360. But what is the graph of tan? So tan is, there is y is equal to tan x, but tan x is periodic in 180 degree. It is periodic in 180 degree. So, and this is a discontinuous, this is a continuous graph, but tan x is the discontinuous graph. This is not continuous. So we you can understand the nature of the graph of tan x. There is, this is y, this is x, this is 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360. What is tan 0? Tan 0 is 0. What is tan 90? Tan 90 is infinity. So infinity, so we have to draw the here dot dot line here. So graph from 0 to 90, the value of tan is increases there. The tan 0, 0. Tan 30 is 1 over root 3. Tan 45, 1. Tan 60, root 3. And so the value is increasing there. So value increases like that, and up to infinity there is infinity. So graph will never touch this line. This is called, also called asymptote of that line, of that graph. And there's in minus 90 also there is infinity. So here is like that. So this way. And again in 180 it is 0 and it will get undefined at 270. So if you use graphic calculator, यदि graphic calculator हामी use गर्यो भने, so what we can see, this graph will go up to infinity and disappear, and it will appear from this side, and it will draw like that. So similarly in the other side also same way, there is graph will go. So this is the graph of tan x, this is the graph of cos x, and this is the graph of sin x. Okay, so now another function is an exponential function. Exponential function. What is called exponential function? The function, you can define this way also. A function f is defined from a to b is said to be exponential function. An exponential function if fx is defined like that. Fx is equal to a to the power x. It is a special type of function is there. Here normally the variable is on the base there is, but here in the base there is constant, power is variable. This power is variable. This is called exponential function. So in this case, in exponential function, actually this exponential function, basically it comes from the compound interest. So if the amount is compoundedly increases, that increase is called exponential increase. Exponential growth is called. Depreciation is called exponential decay, and if exponential increases, that is called exponential growth. So this is called exponential function fx equal a to the power x. So what is the nature of that graph, and in what condition that will grow, and in what condition that will decay? Decay means that will fall down. So here is we can understand fx is equal to a to the, so value of a can be, so let's see here, the value of a cannot be less than 0. The value of a cannot be less than 0 and 1, where a cannot be less than 0 and also a couldn't be 1. So now if fx is equal to a to the power x, so here is the, if the graph is like that, their graph is, this is y, this is x, this is, if you put x is equal to 0 here, a to the 0 is 1, so always this type of function always crosses through the y is equal to 1 from here. So this, the nature of the graph is moving like that. This is called exponential growth. In what condition the graph will move like that? In what condition? So if this is the graph of fx is equal to a to the power x, if the value of a is bigger than 1. If the value of a is bigger than 1, then only the graph will grow exponentially. This exponential growth that is called. Now for a is greater than 1, fx is equal to ax, this is called exponential growth. If the value of a is 0 is less than a is less than 1, what I say? So a cannot be less than 0 and 1. So not less than 0, from 0 to 1, what will be the graph of exponential function? So that is called, in this case, graph will decay. This is y, this is x. So in this case, graph will decay. So here is like that. It will never touch this line x-axis. So x-axis is the asymptote of that graph. In this case also, x-axis is the asymptote of that graph. So it is always passing through the 1. So we can extend this up to there. So you can see it is just going near to the x-axis, but it will never touch the x-axis. So this is x-axis, this is y-axis. So fx is equal to a to the power x. This is called exponential growth, and this is called exponential decay. This is called exponential growth, and this is called exponential decay. So this way we can understand. So value of a. Now the value of a can be any numbers greater than 1, even in the decimal, even in the any integer value. But here in the exponential function, one number is the special function is there in the exponential function, that is called e. That is called e. So if you know the limit, then you can define the value of, so limit n tends to infinity 1 plus 1 over n to the power n. Their value is called e. The limit value of that is called e. Their value is approximately 2.71 to 72. Between them, that value of e lies. So you can find by using the binomial expansion and the limit theorem, we can find the value of e here. So this is exponential. So sometimes, so most of the time you find the exponential function is written like that, fx is equal to e to the power x. So this is exponential growth or decay. So e is the value bigger than 1, is the value bigger than 1. So this is called exponential growth. So this fx is equal to e to the power x is a exponential growth. Okay. Now another function is a logarithm function. What is called logarithm function? So logarithm function is the inverse function of an exponential function. So logarithm function is an inverse function. So it is written like that. Suppose you can define as a function f is defined from a to b is said to be logarithm function if fx if fx is equal to log of x is written there. That is called exponential logarithm function. Now, so but how logarithm function comes, that we have to understand here. So it comes from exponential function, because logarithm function is the inverse function of exponential function. So let's see how to convert this conversion. We have to know. So conversion is, suppose there is y is equal to a to the power x. Y is equal to a to the power x is there. So this is exponential function.